is AP Calculus lesson. No, it's not a lesson. It's a pretest. Pretest 10 solutions. So, again, the rules are if you got full points on 1A, then you can ignore me and you can work on your fix-up. Otherwise, you are paying attention. 1A, it was out of 2 points. So I can do this in red. Red is the scoring, blue is the work. So I need G of 0. G of 0, that's going to be, it's defined as this integral, this accumulation integral from -3 to this x-coordinate, which is 0. So that's going to be the integral of f of t dt. And what is the integral? The integral is the area beneath the curve between -3 and 0. So -3 is right here. Let me make a nice, neat, and tidy line. So right here, and this is the way that I'm going to divide my shape. So I need to find the area of this triangle. This triangle is a 3 by 1, so it has an area of 3, but it's a triangle, so it's half that. This area right here is half of 3, 1.5. And this area of the rectangle down here is 3, so it's 3 plus 3.5. In other words, it is 4.5. That is G of 0. That was 1 point. If you got that answer, plus 1 for 4.5. I guess you should say, I think the technical way of scoring it is you say G of 0 is equal to 4.5. That's the minimum that you need to get that point. And then the next part, I need G prime of 0. G prime of 0, that means you need to take the derivative of the accumulation integral. If you take the derivative, you basically plug x into here and you just do f of that x. So this is going to be equal to f of the x, which is 0. This is height. If you don't know that, I will put it down here in quotes. This is height. H-E-I-G-H-T. So the height at 0. The height at 0 is 1. So this f of 0 is 1. And that is 1 point. So plus 1 if you said something along the lines of G prime of 0 is equal to 1. We're on to part B. 1B. Again, check if you got full points. This was out of 2 points. Out of 2 points. This one, we need to find relative minimum, or relative maximum. I don't know what I'm reading here. Again, relative maximum and relative minimum, all you have to check is if you have a sign change for f prime, or I guess in this case g prime. You don't have to make a table. Table is only when you have an absolute minimum. A relative minimum, that's just going off of our definition of what is an f relative minimum. What is an f relative minimum again, class, for anyone that's paying attention? F relative minimum is where
when G
G prime
prime is going from positive to negative.
goes from a positive to a negative. Well said, yep. So that's what I'm looking for, G prime. Well, G prime is really...
A relative minimum is negative to positive.
Oh yeah, sorry. I don't know why I wrote minimum there. Yeah, I see the confusion.
Oh, that was very confusing. Okay.
We're trying to find the maximum, Mr. Sinnell. Jeez. Relative maximum. So the maximum will be a positive to a negative. That's the answer that goes with this question. Thank you. Yeah, so I'm looking for G prime, and that's really talking about F. So it's really asking about where is F going from a positive to a negative. And again, F is just height. So I'm looking for where height, H-E-I-G-H-T, where height went from a positive to a negative, where it crosses the x-axis. So I come up here, it went from a negative to a positive. That would be a relative minimum. Nothing else, nothing else. It touches 0. It goes from a positive to a positive. That's not a relative extremum at all. And here is our relative maximum. It goes from a positive to a negative at x equals 3. So our answer here is x equals 3. And we need the rationale, the justification. And the justification is because G prime went from a positive to a negative. You get 1 point for saying x equals 3. You get another 1 point for the justification. For part C, absolute minimum. All right, so not maximum. I'm not going to get that mixed up now. Absolute minimum. Whenever you see the word absolute, you have to make a table every single time. You can only find relative minimums by doing the negative to a positive. So when I make my table, I need to find the x values that I'm plugging in. I'm going to have start plus change equals end. But in this problem, there is no start. It doesn't give us any initial condition. So I'm going to ignore start. I'm just going to say x, and then I'm going to have change. There's no start. And that change is equal to the end. All right, filling in my table. And then from there, the values I have to check. I always have to check these two values every single time. Well, technically there's 3, but give me the first 2, the easy ones. Start and end. Where do we start and where do we end? Does it tell us? Oh, it tells us our interval right here. This closed interval from -5 to 4, so I have to check -5. I have to check 4. What's the third value of x that I have to find? There's always 3 things that you check. The 2 that are easy are right there. What's the last thing that I'm missing? It's 2 letters. The CVs, exactly. What x coordinates are at the CVs? So CVs, again, let's write down the definition of what is an FCV. The definition of FCV is where F prime.
Or F prime sine change.
Ooh, that's relative extrema.
Isn't that F double prime? No, because it's F. Or is it?
Okay, I guess if I'm talking about F, yeah.
Or when it equals 0, right?
When it equals 0, yeah. I guess I should be technically saying GCV is where G prime is equal to 0. That would be a more technical way of saying that, and I'm going to change that. Chunk, chunk. So I'm going to say a GCV is where G prime is equal to 0. So I need to set G prime is equal to 0. And G prime is equal to 0 is the same thing as saying F is equal to 0, or where the height is equal to 0. Again, F is just height. So where is the height 0? It happens at 2 spots, here and here. And because we are looking for a minimum, it doesn't make sense for this second point to be a minimum because you have all this positive accumulation. This is more of a maximum point. So I'm not even going to check this point. I'm only going to check this point. And what was the x-coordinate? The x-coordinate was -4. So I need to check -4. Just by having -4 as a candidate, you get +1. +1 if you had a -4. And then from there, I need to find the accumulation. So my integral is going to be the integral from -5 to -3. This is going to be the integral from -5 to -4. And this is going to be the integral from -5 to 4. And all of these are f of t dt. F of t.
Why is the first one -5 to -3? Oh, because we started at
Oh,
What?
I don't know what I'm talking about. Yeah, that's the teacher error. You want to mark it arrow, or do you not log the extra credit? You're too lazy. It's -5 to -5 of f of t dt. I don't know why I wrote -3 there. F of t.
Wait, but listen now.
Yes.
It gives us what it should be started with, -3. Right?
Where does it say it's starting at?
Right there, -3. X, g of x.
Oh, negative. Okay.
Yeah, that would be it.
Okay, so I'm messing up on all of these. Let's backtrack.
This is very confusing.
I'm sorry, because when I make a mistake, it probably makes everything else super confusing. I should all be starting these at -3, because that's how it's defined. So far, so good? And then this is going to be -5, but that's a problem. This being -4 is a problem. This being 4 is not a problem. These two are problematic because these bounds aren't in the right order. These bounds are not in the right order. To turn them into the right order, I need to make it a negative bound from -5 to -3. I can write that a little bit neater. -5 to -3. This is now going to be a negative integral from -4 to -3. And this is going to be the normal integral from -3 to +4. And all of the function here is the same. It's f of t dt. F of t dt. Did I clear up the confusion?
Yeah.
Sorry for causing it. Again, all of this is just talking about area. So what is the area between -5 and -3?
Yeah.
Between -5 and -3, these two triangles right here cancel each other out. This triangle here and this triangle here have the same area. One of them is negative, one of them is positive. So this is equal to 0. Now, no, I guess it's -0, but if you're being, well, yeah, but that's not a thing. Okay, so if I go from -4 to -3, now I'm going from -4 here to -3. I'm just looking at the area of this triangle. This triangle is 1 by 2, so area of 2, but it's a triangle, not a rectangle, so divide by 2 and the area is 1. Area is 1 here. So this is just 1, but it's negative, so it's a -1.
Oh, you were about to put just 1.
I was about to put just 1. And then finally, we have this integral from -3 to 4. So from -3, 1, 2, 3. So from this line all the way to 4. So now I'm counting up all of this area here.
It's 6.5 plus negative pi over 2.
It does turn into that. I'm going to show you how to calculate that. So everything is going to be positive until we get to the very bottom part down here. We can calculate that right now, right away. It's 1 by 1, which is 1, but it's a triangle, so it's 1/2, so it's 0.5, and it's below the x-axis, so it's a negative 0.5. We have these two here. What's remaining is this shape right here.
Same triangle right there.
Oh, I forgot this triangle here as well. This triangle is positive 0.5, which means these two triangles cancel each other out. I really just have 3 plus 1.5, 4.5 plus this area. And to find this area, let me do my best sketch of it. This area right here, where this area is shaded in, is equal to a rectangle where I subtract a semicircle. So this rectangle is 2 by 1, which has an area of 2. This semicircle, well, let's think about the full circle. The first full circle would have a radius of 1, so pi r squared is pi 1 squared, or just pi. But it's half of that, so this is going to be pi over 2. Pi over 2 is our area. 2 minus pi over 2 is this positive area. So I have to add 2 to this 3 plus 1.5, and I get, indeed, 6.5 minus pi over 2. And there's no negative to worry about, so 6.5 minus pi over 2. And again, I'm looking for the absolute minimum. Which of these is the smallest? It is clearly this value of -1. And again, you will get it correct if you talk about what the actual minimum value is and where it occurs. Just put them both. So you say the absolute min, I don't know what I'm writing here, min is -1, and it happens at x equals -4. And our justification comes from the table. So this one I forgot to say at the very beginning is out of 3 points. 1 point was using -4 as a candidate. 1 point is getting this 1. If you get -1, then you have a point. And then finally, you need to have the answer with a table. The absolute minimum is -1, and you have to use a table. So I'm going to say +1 right here for the table. +1 for the table.
Do you think we'd get it wrong if we put, so you know we put x equals -4?
Yes.
For definition? If we put t equals -4, do you think they take a point to it?
Oh, is it supposed to be t or is it supposed to be x? Oh, g is a function of x, so it is x. If you put t, I don't think you would lose. Right. So, but everything here that we're talking about is g. What value of g right here? So if we're talking about g, everything has to be in terms of g, and then g is in terms of x, even though f is in terms of t. So it should be x. I don't think you would lose points. That would be my guess. All right, moving on to part D. That is out of 2 points. So we're on number 1D right now. If you got full points, you can ignore me. If not, you're paying attention. Or even if you had confusion, you're paying attention. All right, I'm looking for point of inflection. What is the definition of function inflection point, IP? It's where, is it f prime or f double prime?
F double prime sign change.
I guess we're talking about g. So g double prime sign change. Thank you, Rochelle. And g double prime is the same thing as f prime sign change. And what is f prime? Is that height, slope, or concavity?
Slope.
It is indeed slope. So I'm looking for where the slope has a sign change, where it goes from a positive to a negative or a negative to a positive. Let's come up to f and look for the slope. Slope is positive, 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 up, negative, 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 still negative, 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 up, positive, 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 up, negative, 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 negative. There are 3 inflection points at x equals -3, x equals 1, and x equals 2. So come down here. Here are our answers. X is equal to -3, 1, and 2, and we need, do we need justification? Nope, you just need the correct values. But if you want the justification, because you're so used to it by now, you can say it's because
What
That's where G double prime sign change.
It is out of 2 points, right?
Yes.
So wouldn't the definition be 1 point?
Nope. So the way that this one is scored, according to the scoring guide, is you get 2 points, but for every one that you miss, you lose a point. Which, I mean, theoretically, you could get -1 on this, but the minimum value you can get is 0.
So then why wouldn't the points be up to 3?
Because they needed it to come out to 9. Yeah. I know, sometimes it's a little bit tricky, but it's +2 here, and then I'll make the note here, -1 for each wrong answer.
Since I'm going to be gone on Friday, can I go to a different room and do the test right now?
Oh, that would be a good idea. All right, and we are on to number 2. 2A. 2A was out of, flipping to my solution guide right here. Number 2 was out of 9 points. Oh, yeah, obviously out of 9, but part A was out of 3 points, so I can put that down here. It's out of 3 points. Thank you, Ben. Yoink. All right, and 1 point for each of these 3 things that we're looking for. So, G of -3. When I plug in -3, that means I'm going to do 2 times -3 plus this integral from 0 to -3, that's a problem, of f of t dt. That's a problem because these are backwards. So I'm going to go ahead and flip these two, switch these, and make it negative. So I'm going to go from -3 to 0. Let's look at -3 to 0. It's talking about this quarter circle from here to here. So this quarter circle, I need to find the area of the circle. The radius is 3, so it's going to be 9 pi, but then it's a quarter of that, so 9 pi over 4. So this is going to be a -9 pi over 4 because we have this additional negative sign, and we have a -6, so our answer here is -6, and then it's going to be -9 pi over 4. You get 1 point there if you got that answer. Next, we need to find G prime of x. So I just need to take the derivative. So I'm going to take the derivative of this one and then add it to the derivative of this one. You take the derivative of each of them independently. It's kind of like distributing the derivative. The derivative of 2x is? It is 2. The derivative of this thing, again, you just plug in x and then just leave it f of whatever that is. So f of x. So 2 plus, my plus got a little bit messed up, 2 plus f of x. There it is. That is 1 point.
I think that was like the only thing that messed me up.
Oh, I'm sorry. And then finally, you need to plug in -3. So G prime, when I plug in -3 into that function I just found, you get 2 plus f of -3. Again, f of -3 is talking about height. So here's a graph of f. When I go to the x-coordinate -3, 1, 2, 3, that has a height of 0. So it's just 0. Or sorry, 2. Forgot the 2. And if you got 2, give yourself 1 point. That was out of 3. We are on to number 2, part B. All right, we need to find the absolute max. Is that a table or is that a definition?
Table.
It is a table. Definition would have been what? Relative. Good, good. All right. So, first, I'm going to make a table. Again, I'm going to do a table of G. G is in terms of X, so these are going to be X values. And then I'm going to have start plus change, and that is going to equal my end. There is going to be a problem here. We'll get to it in a sec, but when I have my table, I'm going to make it nice and small as possible. All right. The 2 easy values to always put in for X are
-4 and 3.
-4 and 3. Yep, the endpoints. The start for all of these are going to be, does it tell us what the start is?
No, but shouldn't it be 2x?
Oh, the start is going to be 2x. You're totally right. This is the start condition, and we'll talk about why that is in a sec. But before we move on to that, the third thing that we're missing, how do we find it again?
It's the maximum, so it'd be when it goes from a positive to a negative.
You're close. It's not, the definition of this point isn't a maximum, though. I mean, I know that's what we're finding for.
CV, right? right?
You find all the CVs. The definition of CV again. FCV is what?
Negative 3 and
Well, what's the definition of FCV?
When
And I guess I should back up because it's really G. So GCV is where G prime does what?
G prime equals 0.
Exactly. So we take the derivative of G prime, which we have right here. Set that equal to 0. So if I do that, I get, so I'm going to do a little arrow here to let you know that I'm moving to the next step. That means that 2 plus f of x must equal 0. And if I take that one step further, subtract 2 from both sides, that means f of x must be negative 2. I don't know why I wrote normal 2. Negative 2. This is saying the height of the graph above is negative 2. Where does this graph have a height of negative 2? And the easiest way to do that is to just look at the height of negative 2, which is right here, and do kind of this dotted line. Where does that intersect? It intersects right there. And it is 2.5. How are we going to find that 2.5? How do we know it's 2.5 and not 2.59876?
Because of the slope.
Because of the slope, exactly. Yes, so this slope, it goes down 3, down another 3, so it goes down a total of 6. If I'm drawing a triangle out here, let me actually make a nice looking triangle. Down like this, and then it comes out like this, and then I also have, oops, I don't want to grab you, out like that. There is my triangle for my slope. This went down 6. I went right 3. This slope here is rise over run, or delta y over delta x. So the slope here, m, is equal to negative 2. So the slope is negative 2. So from here to here, I went down 2. That doesn't help us. That's not in the bounds. That means I went down 2. This is a lattice point. This is a lattice point because I'm going right 1, down 2. Right 1, down 2 would have been exactly right here. Halfway in between here is halfway in between the x-coordinate. So this is exactly half. 2.5. I think that way of describing it is kind of confusing. You can also make an equation, I guess. The equation for this line, I know that it's y equals mx plus b. I don't know why I'm doing that.
And the actual AP test, are they going to give us something like that, and it won't, and we would have to use the slope in order to find it?
I'm winking at you because that's what's going to happen on the test.
Oh.
The test won't have a nice 0.5. It'll be like a third or something weird. But again, I think the way that I solved it the first time was I found the equation of this. The y-intercept was 3, so I said y equals 3 minus 2x. And then I plugged in the y-coordinate. I know that the y here has to be negative 2, so negative 2 is equal to 3 minus 2x.
And then you subtract 3 balls, so it's negative 5, and it would be...
Yeah, and then solve for x. X is 5 over 2, which is 2.5. I think this way is the solid, true method without using too much logic that will solve it every single time. If you just want a procedure and use that same procedure every time, this will be it. Find the equation, which might be hard, then solve the equation. Usually they'll give you a y-coordinate, and you have to solve for that y-coordinate, so plug in for the y.
It's basically the slope formula, but you're plugging in to find x.
Yeah, it's the point. It's not point-slope form, it's the slope-intercept form. Slope-intercept form. All right, so we know that the other CV, which was really hard to find, was 2.5. So you're writing that down with me if you missed this problem. All right, so now it brings us to the next hard question. What is the start value? And Rochelle told us, well, it's just 2x. It's just 2x. And why?
Because that's the start of gx. Right?
It kind of makes...
Because here it's telling us to determine the x-coordinates of the point at which g, not g prime.
Yes, you're right. So you're trying to find g. So not f. So if you plug in g of the start point, so this is going to be...
So it's going to be 2x plus the integral of 0 to negative 4.
Yes, yeah. I think that's a good way of thinking about it too. It's just the start value, and then this is going to be the net change.
Unless you're gonna put the start as in you just plug
Because,
in.
yeah, you're right. So because there's not really an initial condition, I'm going to do air quotes, heavy air quotes, and call this the start. Technically, you can think of this whole thing as a change. And like, there isn't a start. The change includes plugging in -4 in here. So -4 is -8, and you can think of that as the change. But I'm going to do air quotes and just call, yeah, -8 is my start. All I'm doing is I'm plugging in -4. That's all I'm doing right now. When I plug in -4, I get -8 for 2x. When I plug in 2.5, I get 5 for my start, air quotes. And then when I plug in 3, I get 6. And then I need to actually do the second half of that, plug into the second half. When I plug into the second half, I get the integral from 0 to -4. That's a problem. From 0 to -4, it's a problem because these bounds are not correct. Plus the integral from 0 to 2.5. 2.5. Plus the integral from 0 to 3. This is the only problematic integral, so I'm going to rewrite that as, and I'm just going to switch this right here and make it a negative. All right, now I'm trying to find the integral. All of these are f of t dt, f of t dt, f of t dt, and f of t dt. All right, so what is the area between -4 and 0? Well, -4, I have to find this other quarter circle and add it to this quarter circle. I already found that area. So how do I find this quarter circle right here? Well, it has a radius of 1, so it's going to be pi, but it's a quarter circle, so pi over 4. If I add pi over 4 to 9 pi over 4, I get 10 pi over 4, and if I reduce that, that's 5 pi over 2. Is that... I'm thinking I made a mistake there.
What I got is negative. Negative 41 over 4.
Negative 41 over 4.
Yeah, because so it's 9 pi over 4 plus negative pi over 4.
Oh yeah, I forgot to make it a negative. So if I subtract it, then I get not 9 pi, I get 8 pi over 4. Okay, so these two add up to 8 pi over 4. So it's -8 minus an 8 pi over 4. That's equal to minus 8 minus 8 pi over 4 reduces to just 2 pi, so minus 2 pi. So far, so good? All right, next we have to find this area between 0 and 2.5. That might be a little bit tricky. So I have to find this area for the positive, this area for the negative, and then add them up. Is there a shortcut here? Yes. But it's not that great of a shortcut. I think I'm just going to do it the old-fashioned way. I know that for every half that I go over in the x direction, I'm going up and down 1, which means that this value right here is exactly 1.5. So this area is 1.5 times 3. 1.5 times 3 is 4.5, or 9 over 2. But then I have to take half of that. 9 over 2 divided by 2 is 9 over 4. This area right here is 9 over 4.
What I did was just easier. It's just to, can I go on the board?
Yeah, show me. If you want to write digitally, you can write digitally, or you can write with marker.
So I just did that. So that's 1, and then it's 2, 1, so that's 1, and then that's just 2. That's 0.25.
Okay. Just for those of you who are going to be watching the video in the future, she divided it up like this, found area of 1, area of 1, area of 0.25. And that is also a perfect way of solving it. And then this is going to be an area of -1. I should put a negative there as well. A -1 because it's going from 1.5 to 2.5. So 1 by 2. 1 times 2 is 2, but it's half a triangle, so 1. And it's below the x-axis, so a -1. 9 over 4 minus 1 is the same thing as 5 over 4. I guess the decimals do help us. So this is 9 over 4 is 2.25. 2.25 minus 1 is 1.25. So I have 1.25. So 5 was the start plus 1.25. And that's going to equal 6.25. And then finally, the integral from 0 to 3 Oh, then these triangles will cancel each other out. I have a big triangle, small triangle. Oh, they don't cancel each other out, do they? No, they do. Yeah, so it's right in between. So this length is 1.5. This length is 1.5. So they perfectly cancel each other out. Triangle up there, triangle down there. Cancel each other out, and I'm just left with my initial condition, which is just 6. So 6 plus 0 if you want to be pedantic. Love that word math. And we're trying to find the absolute maximum. Which of these numbers is the biggest? Well, that's all a negative. That's just 6. That's 6.25. So our answer is right there. And then we need to actually write it out. So the absolute max is 6.25 at x equals 2.5. Scoring yourself, you got 1 point if you did some work like this where you got the CV at -2. So generally, if you don't even have to get -2, you just have to set g prime is equal to 0 and start setting this up. So if you did any of the work where you set g prime equal to 0, give yourself a point. Your next point comes from 2.5. If you got 2.5 as a candidate, give yourself a point. And then finally, you need to actually have the answer. So absolute max is 6.25 at x equals 2.5.
Wait, you know how it says f of x equals -2?
Yes.
Why is that? How is that 1 point?
So you get 1 point if you somehow set g prime equal to 0. So this plus 1 is very general. It's talking about this whole process right here.
So if we just say g prime equals 0, does that still count as a point?
Yep, you get a point. If you literally say g prime equals 0, you get a point. Even if you didn't do any of the work after that, you still get a point. Whew, that was a long problem. And we're on to part C. Part C is much, much shorter. It's out of 1 point. And we're talking about point of inflection. The definition of G inflection, GIP, is what? Is it G prime or G double prime?
G double prime.
G double prime.
Sign change.
Sign change. And G double prime in our case is?
X equals 0. Oh, sorry.
F prime. Sign change. And F prime is that height, slope, or concavity?
Slope.
That's slope. All right, so we're looking for a slope sign change. So I come back over here. Slope is positive, 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 infinity. Positive, 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 positive. Yep. Negative, negative, negative. So it only happens once, and it's at the x-coordinate 0. So I come down here. It's an IP at x equals 0, and then you have to have a reason. So it's because G double prime sign change.
You know, I learned how to remember whether it's G prime or G double prime. So it's IP, like
Two things.
Yeah,
Oh,
that's
a good way to remember it.
Like IP, sign change.
You give yourself 1 point if you both have the answer and solution, or answer and reason. Answer and reason. And for part D, an average rate of change. So we have to find the definition of average, and this is going back to our last unit, or maybe 2 units ago. So the average is found by doing 1 divided by the end minus start. So 3 minus -4. 3 minus -4. And then you multiply that by the integral from those same bounds from -4 to 3 of the function that you're talking about. What are we talking about? We're talking about f prime of c.
F double prime of c?
So remember, average of f prime of c is just f prime of c. Average is whatever you're talking about. So if I'm talking about f prime of c, it's f prime of, I guess for f prime is in terms of t, right? F is in terms of t, so it's f prime of
for this,
t.
shouldn't it be c because that's what's giving it?
This is more talking about the mean value theorem.
So it doesn't matter what we plug in.
What do you mean?
Like, you put t.
It does matter because f is defined up here. F is defined in terms of t.
Oh, okay.
So if you're being formal about it, you should be putting in a t. All right, and then you have to do some math. So if I take the integral of the derivative, this is using that fundamental theorem of calculus again, that is going to be equaling just f. Well, I guess I forgot my fraction out here. This fraction simplifies to 1/7. 1/7 of f of t, evaluation bar from -4 to 3. And that is going to be equal to 1/7 times, and then when I plug these in, it's going to be f of 3 minus f of -4. And these are both just heights. What is the height at 3? I come up here and I say, when I go to x position 3, 1, 2, 3, the height is -3. So this is now equal to 1/7 times, we have -3 minus f of -4. What is the height at -4? I went too far. Height at -4 is -1. So it's going to be minus a -1. Well, 3 minus a -1, negatives kiss, becomes positive. That's going to be -2. So the answer here is -2/7. All right, this is hard. Explain why this does not contradict the mean value theorem. So what I want you two to tell me, because Ben's off taking his test, what do I need for mean value theorem and what does it prove? I need both of those parts. First, what do you need for mean value theorem? There are one of three things. It needs to be closed. It needs to be continuous. It needs to be differentiable. Which of those three things do we need for mean value theorem?
Or it could be endpoints.
Those are the three options. Yes.
I would say the differential.
Okay, Arrow, what's your guess?
I do not think it's differential.
You think it's endpoints? All right, endpoints is for EVT. Continuous is needed for both MVT and IVT.
I kind of had a feeling that MVT would have like a lot more.
MVT needs two things, but here's a cool thing. MVT needs differentiable, but if it's differentiable, then it's automatically continuous. So MVT needs continuous and differentiable, which is the same thing as saying it needs to be differentiable. So Rochelle, you got it. MVT, you need it to be differentiable at all points in that interval. It's talking about this interval from -4 to 3, which is the entire function. Is this graph of f differentiable at every point between -4 and 3?
Yes.
Remember, it is not differentiable if you have what of these four things? It's going back all the way to unit 1
Endpoints?
or unit 2. Endpoints.
Because it's continuous. Yeah, but that's...
It's not differentiable at endpoints, so but MVT is only applying here, not to the endpoints because they're not equal to. If they were equal to, then that would be a problem. So endpoints are out. What are the other three things? Oh, yeah, what is that called? Infinity slope. Yes, vertical asymptote. This right here is a vertical asymptote. Or vertical tangent, I think is the actual name. This is a vertical tangent. That is one of the four things. You got the second thing. So that breaks mean value theorem. What's the third and fourth thing? Review from unit 2. Horizontal asymptotes are okay. That's when you take the limit as x approaches infinity.
Vertical?
The vertical asymptotes are not okay. That was number 2 that you already got. You're missing 2 of them. Ah, breaks, holes, gaps, all that. That's where it's not continuous.
It needs to be continuous.
And then you're missing what I consider to be one of the easiest things, the fourth one, and it happens on here somewhere.
Is it like random corner things?
Sharp,
Okay.
sharp,
Sharp points.
sharp corners. Where is there a sharp corner? We have a vertical tangent, but we also have a sharp corner.
Up where x equals 0.
Yes. If you have either of those two things, you are not allowed to use mean value theorem because mean value theorem states that you should have this average slope somewhere. You should have that slope somewhere between, where is it going, between -3, -4 and 3. That never happens. I have a positive slope, positive slope, positive slope. The only negative slope happens right here. It's because it suddenly jumped past that -2/7 and jumped all the way to a slope of -2 by having a sharp corner.
If it was curving, then...
If it was curvy right here and differentiable, then it would have had a slope of -2/7 somewhere in that curvy part. You're right. So our answer is, can't use MVT. Can't use MVT because not differentiable. I'm just going to say diff everywhere on the interval -4, 3. And if you need more of an explanation, even that, just saying that will give you 1 point. So you got, this one was out of 2 points. You got 1 point for getting the slope, 1 point for saying what I just said. But if you want to be even more specific, why is it not differentiable everywhere? To make sure the AP graders really know you know what is happening. They know that you know. Because vertical tangent at x equals, what was the x coordinate position? It was x equals -3. At x equals -3 and sharp corner, I'll just say sharp, at x equals 0. Those two things, either one of them on their own would make it not differentiable. But we have two things. All right, we good? That one's going to be on the test. So make sure you know it. Number 3, part A. Part A is out of 2 points. All right, we're finding relative minimum. Is that definition or table? Or sorry, maximum. Definition. Yep. So F relative maximum. Definition is
X equals -3 and 4 because G prime is from going from positive to negative.
G prime going from positive to negative. There it is. So I'm looking for G prime. G prime is by definition. Oh, we don't have G prime in this case. We have just F prime. There's no accumulation integral. So that's a F prime goes from a positive to a negative. What is F prime? Is that height, slope, or concavity on this graph of F prime?
That's the slope. Or the height.
It is actually height, yeah.
I said G prime.
Height. So where does height go from a positive to a negative? It goes from positive to negative there, negative to a positive there, so not there, and positive to a negative here. So there are two values, and those two values are x equals -3 and x equals 4, so comma 4, and you need to justify. So your justification comes from because f prime went from a positive to a negative. Positive to a negative. You need 1 point here for getting those x equal to -3 and 4, and you get 1 point for your justification. Yeah.
I put G prime.
Did I give you a point?
Yeah.
I probably should not have given you that point. But it's okay. You get full points after you do your fix-up. All right. We're on to B. We need to find points of inflection. Definition of inflection on a graph of f is what?
That's F double prime.
F double prime.
Slope.
F double prime. Oh, you're already thinking of slope. You're correct.
F double prime sign change.
Sign change. Yep. So we need a slope sign change. So we're coming back up here to this graph of f prime. On the graph of f prime, f double prime is slope. So our slope is positive, 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 up, negative, 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 negative. Technically negative infinity probably there. Negative, 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 up, positive, 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 sharp corner, still positive, positive, up. Now switching to negative after a sharp corner, negative, 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 negative. So we have 3 inflection points at -4, -1, and 2. So where are we? So x equals -4, -1, and 2, and we need to justify our answers. So it's because we have a f double prime sign change. And you give yourself 1 point if you got all three values, and you give yourself 1 point for the justification. We are on to part C. All right. So we need it to be concave up. Oh man, we only have 5 more minutes. We gotta go through this kind of fast. All right, concave up. F concave up definition. Yep, greater than 0, positive, greater than 0. So that means we're talking about slope. Slope is greater than 0. So where is the slope greater than 0? That means slope is positive. So it's positive between -5 and 4. So -5 to 4. And we also have another interval where it's also positive, negative, negative, and now it's positive from -1 to 2. From Oh, sorry, yes. Teacher error. You should be logging these, Arrow.
Well, I wouldn't turn in the thing at the end anyway.
I would just collect it in your binder. You wouldn't even have to check it off.
You didn't do that last time. But anyway.
Okay. Because you have to say f double prime is greater than... Oh, and also has a positive slope. So that's actually wrong. It has to be concave up and have a positive slope. We forgot the second part. So
it would just be -1 and 2.
So this has a positive... What am I talking about here? So now we have to have a height that's above the x-axis. So this definition of positive slope. What does it mean to have f positive slope?
F double prime sign change.
When the slope is positive, the definition is, we're talking about f prime. F prime has to be greater than 0. So we're talking about height here. The height has to be greater than 0. Where do both of these things happen? So I have to have a positive slope. We have those intervals, but narrow it down to where we have a positive height. So we thought that this interval right here was okay, but that height was negative. So eliminate it. The positive slope and positive height only happens between 1 and 2. So change our second interval to positive 1 and 2. So our rationale is because f prime and f double prime are greater than 0. All right, very, very quickly. I don't think we're going to have time for the multiple choice. If you want to talk about multiple choice before the test on Friday, come in during lunch, after school today. I'll be here after school today a little bit. Or I think that's the only 2 times. Absolute minimum. Absolute minimum means I'm using table or definition. Table. So I'm finding the x values. I have to do the start, I have to do the end, and I have to do the CVs. CVs are wherever f prime is equal to 0. There are 2, 3 values that I should be thinking about, but I'm looking for a minimum, so I want negative area beforehand. This is positive area beforehand. Don't worry about it. This is negative area beforehand. Let's use that point. This is positive area beforehand. Don't worry about it. This is the only one that can give us a negative value or a minimum. So we're only going to be looking at x equals to 1. So I come down here and put 1. Our start for all of these is 3, 3, 3. That comes from this initial value that told us that it is 3. Our integral will start at here at 1. So it's going to be the integral from 1 to -5, that's a problem. The integral from 1 to 1, which is going to be nothing. The integral from 1 to 5. And then we're plugging in f prime here. F prime of x dx. F prime of x dx. So now I'm finding area under the curve. I have to come back up here, and I'm going to very quickly do that. The area for this one is pi over 2. The area for this one is -2 pi. The area of this entire triangle is 3. The area of this triangle down here is -0.5. So from there, if I add them all up, I should get, so our start was 3, and then I have to subtract, because I'm going to have to switch these bounds. If I switch these bounds, it's going to become a minus, so I'm going to subtract here by using this. And when I add up all of those from -5 to 1, I actually get a negative value, so it's going to be minus a negative 3 pi over 2. And that's going to just turn into 3 plus 3 pi over 2. And this one is going to be, again, I have initial condition of 3 plus, and when I get this integral, it's going to evaluate to 2.5. Yes?
No, I'm good. So it's just
Well,
time
for
consuming. Yeah, you understand.
-5 to -3.
Yes. So -5 to 1, right?
No,
Just
Yeah.
'cause, like,
So
all
from
the
negative 5 to negative 3, that'd be pi over
You're not-
4.
This should be pi over 2, shouldn't it be?
It's pi over 4, wouldn't it?
So it's not a quarter circle, it's a half circle. So the radius is 1, so it's pi r
it's
squared.
okay, I see.
Got
Okay,
it?
so it's half number.
No, it's good to ask questions. And we have all these values, and we're trying to find the minimum. So obviously 3 is smaller than 3 plus 3 pi over 2, and obviously 3 is smaller than 5.5. So the answer is 3. So we say absolute min is 3 at x equals 1. And we have negative 1 minute left. 1 point if you considered x equals 1. 1 point if you considered both the endpoints here and here. And 1 point if you got your answer. And that was out of 3 points. Again, if you want to talk about multiple choice, please come and see me during lunch or after school today.